Hello, welcome back. Today we are going to continue again with the quadratic equations. Right now I think we have become very good in this, and we are going to take off now. We have this problem here now. We have to solve for x. Look at it. It's 1 minus a squared, 1 minus a squared here, factoring x plus a minus 2a factoring 1 minus x squared is equal to 0. You see, and first of all, let's rearrange this. These are all factors, okay? So if I get smart here, I say 1 minus a squared is 1 plus a factoring 1 minus a, then factoring x plus a, and also I know that 2a is a plus a, okay? Factoring 1 minus x squared is 1 minus x, factoring 1 plus x, we say is equal to 0. Okay, this is one part, this is another part. And if you look at the sequence here, 1 plus a plus a, 1 minus a, 1 minus x, a plus x, 1 plus x. What does it say to make this one 0? Let's say like x is equal to a. If x is equal to a here, watch, we get what? We get a here, we get a here, we get a here, and we have 1 plus a, 1 plus a. We have 1 minus a, 1 minus a. We have a plus a plus a. So that means x is equal to a is a solution, so x1, the first root, is equal to a. Very good result for us, okay? Now let's rearrange the original equation to get x squared and x's and the constants. We have 1 minus a squared times x plus a minus 2a times 1 minus x squared is equal to 0. So let's develop this one. We have 1 minus a squared times x plus a times 1 minus a squared minus 2a plus 2ax squared is equal to 0. Okay, we can rearrange that. We can say 2a x squared plus 1 minus a squared x plus this quantity. That means we can leave it as it is, a factor 1 minus a squared minus 2a is equal to 0. Guess what? We have our quadratic again. We can say this is our small a, original a, this is original b, and this is c. Okay, now let's apply what we know. We know that x1 plus x2 is equal to minus b over a. We know that, right? So let's apply that. We know x1, we said it was a, so a plus x2 is equal to minus b, but b being that is a squared minus 1 over a. A is The original a is 2a here, okay, if we apply this, okay. We apply this formula. This is for the regular quadratic, not to be confused with the a we are having here now. So we can say that x2, if we subtract a from both sides, is equal to a squared minus 1 over 2a minus 2a squared over 2a. If I multiply this a by 2a, I get 2a squared. So x2 is equal to a squared minus 2a squared. That's minus a squared. That means it's minus 1 minus a squared over 2a. We have solved our problem. So x1 is equal to a and x2 is equal to minus 1 minus a squared over 2a. That's what the problem is what we wanted to find actually, okay. So I put this together. So every time you get a problem, you have to look at it and see what you can do about it, okay? Because sometimes the solution is simpler than what you think. Thank you for watching, and see you in the next video here. In this one we have problem number 8. We have been given the equation x squared plus mx plus 9 is equal to 0, and they want us to find the positive value of m to get a double root for solution. So that's quite easy. So what we are going to do is, we know that the condition is delta should be equal to 0. Here we have a is equal to 1, b is equal to m, and c is equal to 9, okay. So what we are going to do is, we are saying delta is equal to m squared b squared minus 4 times 1 times 9 is equal to m squared minus 36. So if delta is equal to 0, that means m squared minus 36 is equal to 0. M squared is 36. M is equal to plus or minus 6. But the problem says the positive value, so we take 6. So when m is equal to 6, we get the new equation will be x squared plus 6x plus 9 is equal to 0, and we can find another delta. We call it delta 1 is equal to 36 minus 36. As you can tell, this is equal to 0. So x, the double root, is equal to minus b being 6 here. This is minus 6. Now square root of delta over 2a over 2 is equal to negative 3. So the root is negative 3. When we take the positive value of m, we can substitute here. We can say if we have negative 3, we have 9 minus 18 plus 9 is 0. So it's verified. Thank you. Hey, number 9. Number 9 is a curve. We have a graph, and we have to find the equation representing that graph. So we know that already. If we look at the curve itself, we see that this one is a root and that one is a root. So x1 is equal to 3 and x2 is equal to 6. But we can now know that x minus the first root 3 times x minus the second root 6 is equal to 0, represents an equation of this graph that will get it to 0 here. So if we multiply, we get x squared minus 6x minus 3x, so minus 9x plus 18 is equal to 0. And we can verify that now. We can put it in our form of a factor in x minus h squared plus k. Okay, so we can say here that we have x minus 9/2 squared minus 9/2 squared plus 18 is equal to 0. Okay, so we can say that x minus 9/2 squared minus 36/4 plus, it's not 36, so it's 81 here, okay, plus 72/4 equals 0. We get x minus 9/2 squared minus 81 minus 72 is 9 quarters is equal to 0, but we can say that x minus 9/2 squared minus 3/2 squared is equal to 0. Okay, or we can simply leave it in this format. We can say the function f of x is equal to x minus 9/2 squared minus 9 quarters. Now if we look at the curve, we can see that the vertex, this vertex here, is centered at 9/2. 9/2 is 4.5 for x. We do it here. This is our axis of symmetry, and the other one is negative 9/4. We divide 9 by 4, we get 2 something, 2.25 probably. If you look at here, this is exactly what it is. So this is our final equation, and this is what we're looking for. Okay, problem solved. Let's check the next one. Hey, number 10. This one is as simple as it can get. Okay, if you look at it, they are asking us to find the equation. Actually, I would say the function represented by this curve. Okay, but guess what? We have something here very important. First, we see that it's opening down, so a is negative. And if you look at the variation, 1 for 1, 2 for 4, and so on, that means a is equal to 1. A is equal to 1, but it's flipped, so it becomes negative 1. So we don't have to worry about a. So let's look at the other stuff. The vertex v is at 0, x is 0, and y is negative 2. So all we have to do is, we can say the function is negative a, so negative 1, so minus x minus 0 squared minus 2 plus k is 2 here. So that it simply means that the function is of fx. Let's change the color here. Is equal to negative x squared minus 2. And that's it. That one was very simple. Okay. Hey, we have number 11 now. It's not number 10. So I'm going to change this. This is 11. So we have to find the function for this curve. All we have to see is the vertex here. The vertex is at x is equal to 2 and y is equal to 1. And this one is opening up, so a is positive. And if you look at the variation 1 for 1, 2 for 4, that means it's a perfect scale. A is equal to 1 here. Okay, so all we have to do is function. Let's change the color. So f of x is equal to a is equal to 1, factor in x minus h is equal to 2 squared plus k is equal to 1, and that's it. We have our function. If we want to develop this one, we can just find out it was x squared minus 4x plus 4 plus 1 plus 5. Okay, that one was short.